In this video, we'll be starting looking at a new method, the reduction method, and we'll be looking at it for 4 players here, but we can easily expand it to n players, which I'll explain at the end of the video. So what I've drawn here is just a table, which is the easiest way to explain this method because it's very algorithmic. So at the top I have these labels, which round it is, what piece we're dealing with, A, B, C, and D, which are 4 players, and I've color-coded them for convenience for later on, and the outcome after each round. So this particular game will consist of 3 rounds. And let's just jump right into it and see how to play. So we first have to pick a random order for our players. So for convenience, I've put the order as A, then B, then C, then D. But really with 4 players or any amount of players, you need to just randomly pick an order. And we'll see why, because this last player has some kind of advantage, which we'll see. So first step of the game is to have player A, the first player, cut off a piece that he deems is worth a fair share to him. So it has to be worth $2.50 to him. Okay, and it doesn't have to be worth exactly $2.50, but we'll see either in this video or the next video why it's advantageous for him to cut off a piece that's exactly worth 1/4 of the value to him. So let's say he cuts off this piece right here, which is 1/4 of the pizza right here. So now let's draw bigger the piece that he's cut off. Okay, so now it's B's turn. B has 2 choices. He can either reduce this piece and claim ownership of it away from A, or if he thinks this piece is not even worth $2.50, then he can just pass. But let's say he does think this piece is worth equal to or more than $2.50, so he will reduce it. So let's say he reduces it by this much, and he has this new piece here. So let's analyze what just happened. A previously had ownership of this whole red piece, this 1/4. But now B came in and reduced the piece. And by reducing it, by the rules of the game, he now owns this reduced piece. And this remaining part just goes back into the whole pizza. So now A no longer has ownership of this piece, and he has to wait until next rounds to maybe get a piece for himself. But B right now owns this piece right here. Now C has the same opportunity. C can say, do I think this piece is worth more than or equal to $2.50? And if he does, he can reduce it and take it away from B. So let's say that he does think so, and he reduces it right here. So now he reduces it to a piece that's about this much in size. And let's say this is 45 degrees, so this is 1/8 of the whole pizza, or 1/2 of the original red slice. And now he has ownership of the smaller piece, and this remaining portion that he cut off just goes back into the pizza. So now D has the same option. D can say, is this worth more than or equal to $2.50 to me? And if it is, he can reduce it more and take it for himself. But let's say he does not think so. He doesn't think this is even worth $2.50, so he doesn't want any part of it, because if he takes this, he won't be getting a fair share. So he's going to pass. And since there's no more players to play, the outcome is that the last owner now gets the slice. So C, who is the last owner, gets it. So we're going to say C gets it. So C is sent home with his piece, and now he's no longer playing, so we'll put X's in the rest of his rounds. So that's 1 round. Now let's go to the second round and see how this just plays out again. So now, how much pizza is left? Well, it's going to be the 3/4 on this side, plus the 1/8 that was put back. And this missing 1/8 is the piece that has gone to player C. So now we just play again. Now the rules have changed, because now there's only 3 players left because C is done. So each person wants to cut off a piece they want to pick a piece that's 1/3 or more of the value of the pizza to them. Now something to be careful of here is when we had the whole pizza, it was worth $10 to everybody. But now this much pizza might not be worth the same amount to everybody, because that piece that was taken is probably not worth the same amount to everybody. So maybe this much pizza is worth $9 to A, maybe it's worth $8 to B, maybe it's worth $7.60 to D or something like that. So we can't say that they have to cut off a piece worth $2.50. We just have to be general and say that they have to cut off a piece that's worth 1/3 or more of this remaining value to them. So let's say A does exactly that, and he cuts off this piece right here. So he cuts off this 1/4 and the 1/8 that was put back. So now let's draw bigger his piece. And now the game proceeds as normal. So now B has a chance. B can say, can I reduce this and can I get 1/3 of the value from this? So if he thinks this piece right here is worth more than or equal to 1/3 of the remaining pizza, then he will reduce it. And let's say he does think so, and he reduces it he cuts it right here, so that this portion he takes off is 1/4 of the pizza. So let's draw it here. So this is 1/4 of the pizza, and the remaining portion goes back into the pizza. So C is done, he doesn't get a turn, and now D has the same option. D can say, well, do I think this is worth more than or equal to 1/3 of this remaining pizza? And if he does, he can reduce it and take it. So let's say he does think so. So here's another little nuance of the game. We said D has an advantage, and the reason is this. even though technically you have to reduce a piece to take it away, if you're the last player, you're allowed to just take that piece away. And we call that move reduction by 0%. And here's why that works. So he's allowed to kind of just lie and say, hey, yeah, this piece is worth exactly 1/3 to me, so I don't want to reduce it, and I just want to take it. So since there's nobody after him to discourage him from lying, like these other people had people after them to discourage them from lying, he's kind of allowed to cheat, and since he's allowed to cheat, we just make this cheating okay in a sense. So he's allowed to reduce this piece by 0%, and so now that becomes his piece. So he has not reduced it at all, technically reduced it by 0%, but now he gets that piece. So we say D gets it. Okay. So now he's done also. There's no more rounds for D. And now the only people left playing are A and B. So this really becomes a 2-player divider selector game, but we'll just keep playing it as if it's a reduction method game. So now let's draw how much pizza is left. So it's the bottom half of the pizza, and it's this little 1/8 portion that was not taken in the last round. So now A again has to cut it so that now, since there's only 2 people left, he wants to cut it so that he gets half the value of the pizza. So he's going to cut a piece that's worth half the value of the pizza to him. Let's say he cuts it right here. So he's going to cut this piece right here, and this piece, let's say, is this 1/4 right here and this 1/8 right here, which leaves 1/4 of the pizza right here remaining. So now B can say, do I want this? Is this worth more than or equal to 1/2 of the pizza to me? And let's say it is worth more than or equal to 1/2 of the total value of the remaining pizza here. And since he's the last player to play, since C and D are done, he can also do that reduction by 0 move. So he's going to reduce, color is blue. He's going to do reduction by 0%. Which means that technically he's supposed to cut something off, but since no one's after him to discourage him from doing that, he's just going to go ahead and take the piece. So now we say that this piece right here, B gets it. So B is given this red piece right here, and A, as you might imagine, is just given the remaining, we'll put it in black, he's given this remaining 1/4 right here. So this goes to A. So through this method, everybody gets a slice. So C was taken care of at the very beginning, D was taken care of in the second round, in the third round, A and B got the remaining slices as they cut it in half. So we see that this method is very algorithmic, very it's straightforward. It's like you do this, go through the players, and then at the end, someone gets a slice. That's the great part, because after each round, someone's getting a slice. There's no rounds where nothing's happening. So I'm not going to do a video on N players for this, because you can see how if you had N players, it would just be more rounds and just more of this. But I will do a video on why everybody gets a fair share, because although this method seems neat, you might not be initially aware of why everybody's getting a fair share. You might think somebody's getting cheated out, but we'll make sure that everybody's getting a fair share. So until next video.